And so it is. Welcome to Relationships in Ruby. Let's talk about them. Oops, that's not at all the one that I wanted. I want this one. All right. So, let's talk about what we mean by relationships. So we're talking about this one today. Something that has an arbitrary number of something else. So, for example, we're talking about dogs and owners on Tuesday. Oops. Nope, other way around. Our simple model for that was that one owner can have a bunch of dogs, but each dog only has one owner. You could also model that other ways. You could say, like we did on Tuesday, that each dog can have more than one owner. It's cool. It's allowed. This stuff is very specific to the problems you're trying to solve. Let's think of some other like one-to-many relationships. So I could say that one cohort has many students, but each student is only in one cohort. So we call these one-to-many relationships. Sometimes you'll write that as 1:M. It means the same thing. So as you might imagine, there's also a one-to-one and there's a many-to-many. Neither of them are quite as common as one-to-many. In fact, a many-to-many is just two one-to-manys. So of all the relationships that we can model, this is the one that we're going to do most. 90% of the time, 95% of the time, we're decomposing relationships into one-to-many. Give me a suggestion for another one-to-many relationship.
I personally own 2 cars.
Okay, but both of those cars are only owned by you,
Correct.
right?
Yep.
So I say driver and cars, or car. This is a sort of tricky thing. Whether you make these singular or plural, I'm kind of like going back and forth a little bit here. It technically doesn't matter. You can do it either way. Rails generally prefers that you do them plural. Good common fucking sense would indicate that you do them singular. That's how I was raised. But the idea is still the same either way. What else? Give me some more one-to-manys.
Artists and songs, or an artist and his songs.
Ooh, depending on the application, sure. So you could say that, well, in my app, an artist can have a bunch of songs, but each song only has one artist. But then maybe down the road, we need to accommodate for duets and what have you. So at that point, the relationship changes. So you can have that relationship. It's heavily dependent on context. Cool. Give me another one.
What about stores to products?
One store has many products and every product is only in one store? So again, maybe there's a context where that's the case. That one, probably not. If I get Sony 1000 XM4s, I can get them at Best Buy, or I can get them at Micro Center, or I can get them at Target, or I can get them at Walmart. So that's more likely to be a many-to-many relationship, but could be. Give me one more.
States to countries or country.
Sure. Love it. Country has many states. Each state is only in one country. Sure, that one works great. Now, there's more depth to this kind of modeling. We generally don't go into it in this program. But I got a whole degree in this shit. So there's a lot more to this. To give you an example, you could say that an owner has 0 or many dogs, because like some people have no dogs, some people have 1 dog, some people have 100 dogs. With something like states, it might be a little bit more complicated. You could say that a country has to have at least 1 state and it can have more. We'd have things that might have, well, a minimum of 3, but kind of an arbitrary number after that. Or they might have 3, 4, or 5 of them. It's called cardinality if you want to geek out on it. Otherwise, this one-to-many will take you an awful long way. So what I'd like you to do now is I want you to come up with 2 more examples of one-to-many relationships, something that could feasibly be a one-to-many relationship, and slack it over to me. Examples of one-to-many relationships. Go! Good job, Bradley. Haley just made me crack up. That's good. Oh, this is a tricky one. So I got recipe to ingredients. Maybe, unless the same ingredient can be used in more than one recipe. That's where that gets tricky. Solar system and planets is good. Book and pages is good. Cool, very nice. So this is the idea of relationships. We use these over and over and over again in our apps. So if let's see, I'm just going to go to something. If I was going to, oh shit, I blocked Twitter at the DNS level. So we'll talk about this some other day, probably in mod 3. But when you type in something like twitter.com, it uses a phone book called DNS to look up what the IP address of that computer is. So it's like an address book or something where you go, Kyle's house. And you go, oh, well, that's in Stapleton. So I set it up so that my computer, when it tries to look up the IP address for Twitter, just like returns nothing, so that I can't actually go to the site. Let's try another one.
Is that a productivity measure or?
Yeah, like Twitter does nothing good for my life. Neither does Fartbook. So
Yeah.
block them.
Both poison.
Both poisonous. Well, shoot, let's go to the Firebase site. So we got a pretty clear hierarchy here. What kinds of relationships do you see happening in this?
Website that includes 5 modules, and then a module containing different lessons.
Standards.
So, yeah.
So one-to-many with module and standard. Cool. What else?
One-to-many with standard and lesson, or standard and lab.
These resources here.
Yeah.
It's technically a many-to-many because these can show up in more than one thing, but that wouldn't have to be the case. I could absolutely have separate resources that are only owned by a standard. Ooh, what about standard and assessment? What's the relationship there?
Seems like many to one, so maybe it's the same thing, but like many standards point to one assessment.
So you're saying that you'd have the same assessment for more than one standard?
It's 1-to-1, huh?
Yeah.
So the way that like all of these work, where there's only one assessment, 1-to-1 would be the same assumption there. That another way you can do that is 1-to-1 is an is. So you say a standard is an assessment. That's not too far off. Now, I'm also using the word assessments here, which implies there could be more than one of them, in which case what?
It would change from 1-to-1 to 1-to-many.
Exactly.
Have another assessment.
Exactly. Each assessment would belong to one and only one standard, but that standard could have more than one assessment. Cool, very nice. Let's do one more. If I go over to the video section, can we think of like the discrete things that we have happening on this page and what their relationships are?
You've got like one video to many tags.
Yep.
the videos page has many videos, but
Mhm.
each video is only on the video page.
Okay. But so these tags here, so we say that one video here can have many tags. But this Ahmed tag, can I only use that on this video?
No.
If so, we're in trouble. It shows up here more than once. That's data modeling.
One search bar, many results.
So some of those things, not everything it has like a modeling relationship like that. For example, there's no relationship between the search bar and the results or anything like that. We're talking about different discrete things.
What about like the specific search that you put into the search bar and the
well,
results?
Potentially. So it has to do with whether or not you're saving that or not. When we're talking about these modeled relationships, this is data at rest. This is state. So if I search for Rails videos, you could say that this one query has these many results, but also these same results can show up in more than one search. For example, they show up in Rail also. But still,
Okay.
probably not too useful to model it unless you're going to save it somewhere. But yes, that is technically a relationship.
Or what about the tag? Well, no, because I guess the videos have multiple tags.
Yep. Each video has multiple tags. Each tag can be used in multiple videos, so many to many. Now, if the tags had to be unique, if I was only allowed to use the JS tag one time, then we could say that's a one-to-many. Cool. Coincidentally, that's modeling domains using ERDs. An ERD is this shape. The thing with the little, they're called crow's feet.
What does ERD stand for?
Entity Relationship Diagram. Owner and dogs are entities. This line is their relationship, and it's in a diagram. ERD. Cool. So let's talk about how we model these things in Ruby. Let's see. So we've got, let's do cohort and students. All right, so I'm going to make an environment RB file. Don't follow along with this. I'm going to make a cohort file. I'm going to make a student file. And what I want to do is go into the environment file and require pry. I'm going to require that cohort file. I'm going to require that student file. And then I'm going to binding.pry. So I should be able to Ruby environment RB and be right here, ready to go. All right, so now I'm gonna make this a Git, go ahead.
So Damon, when he puts a binding not pry in, he often puts like another character, like a zero
A
underneath.
zero after it.
Do you not
used
feel
to
like
have
that's
to do that.
necessary?
No,
Okay.
you had to do that in the last version of Ruby. I don't think you have to do that anymore. I like when I first started at Flatiron, everybody did that, and they're like, everything breaks if you don't do it. And then I stopped doing it one day, and nothing bad happened. But I think in Ruby 3 that was a problem. Or sorry, in Ruby 2, something like that. All right, so what I'm going to do is I want to make this a Git repo. I'm going to push it up to GitHub so that you can pull it down. To do that, I'm going to git init to make an empty Git repo. I'm going to add all of these files, stage them. I'm going to commit them. Cool. So I have made a Git commit in my Git repository. I go over to github.com. I make a new GitHub repo. Student cohort relationships. I'm going to take this Git URL. I'm going to git remote add origin, and I'm going to git push origin master. And now I've taken my Git repo on my computer and copied it over to this repo on GitHub's computer. And now what you're going to do is go to this URL that I'm throwing in chat. And you're going to go fork it. That'll make your own personal copy of it. And then once you've done that, you will clone it with git clone, whatever the fuck. It'll make the folder for you, FYI. And then we'll all be on the same page. Sick. I'll give you a second to do that. Fork, clone, clone. Come on. Shit. There we go. Clone. And then you'll have all my files.
Just opens the welcome page. I don't know why.
What was that?
It just opens the welcome page. It also repeatedly prompts me that VS Code wants access to my downloads, which I was like, okay. And it just didn't, I guess.
All right, why don't you screen share? Let's troubleshoot.
Please don't judge how much stuff I have open.
All right, so it looks like you forked it correctly. You've got the clone. So when you get cloned that made a folder called student cohort relationships. Give me an LS. There it is right there. You want to be in that folder when you open code. Otherwise, you opened it in your entire home folder.
Voila. Thank you.
You're beautiful. All right, so give me some visual confirmation that this is working okay. Give me a thumbs up if you got it pulled down.
I'm still trying to get mine done.
Okay, why don't you screen share and let us help you.
I'm just going to the folder now. Okay.
All right, so go ahead and clone it down. Oh, actually, fork it first. Upper right corner. Yeah. So that'll make your own copy of it. Now clone. And then do git clone and then paste that URL in.
Git clone.
Very nice. Now go into the folder that it just made. Cool, and you're good to go. All right.
Thank you.
You're very welcome.
Do I need to stop sharing?
No, I got you.
Okay.
So, all right, so we have these files here. First thing we want to do is make classes in those student and cohort files. Go. Cool. When you have that, you should have something kind of like that. Doesn't need to be anything else just yet. Next thing, we can do this from either side. We can say a student enrolls in a cohort, and we could say that a cohort enrolls students. Ideally, we can do this in both directions, right? Let's pick one. Let's say from a cohort, we add a student into the cohort. Neat. So we're going to make a method called add student. What argument do you think, or what parameter do you think we have for this method?
Student.
Student. You want to add a student? Give me the student to add. Now this gets a little tricky. What do you think we're going to do with that student to add them?
Push them into an array?
Yeah, of some kind, right? So we'll have like some students array that we're like shoveling them into. But this is the tricky part. Where is that array going to come from? Because if I do something like this, that works. But as soon as the method's over, students goes away.
Should it be a class variable?
That's exactly what I think it should be. So, or actually, no, here's the problem with that. If I do it as a class variable, like that, make it an array. I can totally do that. Can anybody spot the problem?
Students is also a class variable.
You'll be tracking every student in every cohort with that.
In every cohort. Because think about what the options, the objects for these are going to look like. It'll be things like new friends is cohort.new. GIT is cohort.new. mprior is cohort.new. So we get these three objects, and then if I say mprior.addStudent, Also have to make some students. Let's say something like Gordo equals student.new and Tony is student.new. I can say, all right, I'm adding Gordo to Empire, and then I'm adding Tony to GIT. But now, when I do cohort.students, I'm going to get back Gordo and Tony, even though they're in different cohorts. So that's probably not what I want to happen.
Does this need to use like a nested data structure?
Nope, not quite.
So would it just be an instance variable for each cohort then?
Exactly. Each cohort is going to keep track of their own students. So how do I initialize an instance variable?
Initialize?
Hey, go, go, go. Cool. So now I can move this into here. And now we're getting somewhere. Questions about that? Cool. Make sure your screen looks like mine. Now I probably want to be able to read my students also. That's a good place for an adder reader for students. Or students is a symbol. I'm not doing something like that. It's just a symbol. Okay, so I can successfully add students to this cohort now. Here's the like relationship-y part of this. How do I figure out what cohort I'm in from the student side?
Is that where am I?
Yeah, it could just be cohort. So like we're gonna have a method called cohort. How do I return back the right cohort for whoever that student is? Think to yourself for a second. I'm going to call on someone. What could go in this method that would tell me what cohort, if any, I'm currently in? Michael Devoy, what do you think?
Sorry, I was muted. Honestly, I'm not sure.
All right. So this has a list of every student that's in a cohort here. We actually need one more thing over here too. We need to keep track of every cohort we make. Michael, do you remember how to do that?
The add all.
Yeah.
And then shovel it in.
Shovel what in?
Self.
There we go. Okay, with those ingredients, we should be able to figure out what cohort I'm in. If I'm in GIT, it's a couple steps.
Do we need to be able to read that at all too first or no?
Yeah, oh, we do. Good call. So I can read that like cohort.all from over
Right.
here.
So what did you cohort.all.student?
Ooh, almost. So think about what cohort.all is going to give us back. Michael, what does cohort.all resolve to?
A list of every student that you initialized.
Cohort.all? That's going to give me that, which is a list of every, not student,
Oh, every cohort?
every cohort.
Okay.
All right. So let's see. Daniel, pick it up from there. Any ideas what I could do if I have every cohort? What am I trying to do? How do I narrow every cohort down to my cohort?
You've already identified self.
What was that?
You've already identified self.
Yep.
So you just define self in the student class?
So self is going to be in an instance of student, like for Tony or Daniel or Derek, self is going to be Tony or Daniel or Derek.
Well, we want to find the cohort, correct?
Yes.
Okay.
I'll give you a hint. It's an enumerable.
Find self or find cohort?
Ooh. Hey, find is the trick. Here's what I want to do. I want to take, are we out of time? I want to take 4 minutes, see if you can figure out what this code should be, and then Slack it to me. Find is part of it. Go. Give it your best shot. Two minutes. Figure out how you would find out what cohort a student is in. All right, send me whatever you got.
Kyle, you said it was 3 backticks to make it look like code in these Slack messages?
You got it. You got to surround it, and it's got to have spaces on either side of it too.
Oh.
So an empty line, 3 backticks, whatever code you want to have, 3 backticks, an empty line.
Okay.
You can also use the code block button on the line where there's like bold and italics and such. The very last thing is the code block button. If everything is highlighted and you click on that, it'll push it in there.
Ooh, all right. So everyone's like kind of in the ballpark of it. One of you got it. So if I'm getting back every cohort from this and I want to find the correct one, now like this is heuristic number 1 when you're writing like really code in any language. So if I have every cohort and I'm using some enumerable method with it, plural, singular, cohort.all, that's cohorts. So the thing in the block variable, that's cohort. It's not student. And another thing that I see people do with these is they'll try to get too clever with it. They'll say like, all right, well, this is cohorts. So the block variable is going to be individual cohort. Or like they'll come up with a new name for it. Just go cohorts, cohort. Student, student. Dog's, dog. Makes it way easier to read, and it's a lot less cognitive work also. All right, so we get access to every individual cohort here. So if I have an individual cohort, how would I know whether or not I'm in it?
Look for self.
Okay, self is going to be some part of this. What am I comparing self against?
Student.
Student.
So let's take a look at what we have over here. I only have one thing that can give me access to every student. Which method is that?
Add student.
At students is what it is in the class. If I'm accessing it from the outside, all I can do is call methods. So what's the method called?
Self.all.
Ooh. Self.all, that's for the cohort. This is what we use to get all of the cohorts here. That was that self.all.
How many more are left? Initialize students. Huh?
So what's that do?
Dot student.
Yeah. So that adder reader is exactly like if we typed that. Instead of typing this, we typed this instead. They mean the same thing. So I have this students method that's going to give me back all of the students that have been added to this array. So if I do cohort.students, I get that array. So how can I compare that array to self in a meaningful way?
Did dot include self?
Ta-da. If that cohort's students include me, I'm in that cohort. Pretty cool.
Kyle, would the any question mark work as well, or would that, I know include would specifically find that, would the any question mark also work on that?
Might be an alias.
I don't know. I feel like I've seen that somewhere, but unless.
All right, so I'm going to go over to the docs for array and look at the any method.
I have .any returning anything that's is anything truthy. So I feel like that'd be too broad.
Let's see. Passes each element of the collection to the given block. The method returns true if the block ever returns a value other than false or nil. Okay, so if I'm going through each individual cohort, I go, all right, let's see what any takes in. Any takes in a block, it looks like. So we would be doing something like and then we would have student. And then we could say student. That would work. If that returns true for anything in that array, then we should return true. And the first thing we return true for from a find block, that's what gets returned out of find. That'll work. That feels a little bit more terse to me. And a little bit like, so we do some pretty circular logic, or not circular, roundabout logic to get here. Whereas this is saying like what we want and why we want it. That's why I like that one. Moment of truth though, we gotta see if this works. So let's go over to our environment file and let's make some students and cohorts. I'm gonna make Ben is a new student. Derek is a new student. And Gerald is a new student. And then I'll do our 3 cohorts. So new friends and M prior and GIT. Cool. So I'm going to say that Ben and Derek are new friends. And I'm going to say, Gerald, you got promoted. You're going to be an M prior. So what we're hoping is that add student works, puts them in the right cohort. And then we're also hoping that we're going to be able to look at Ben and Derek and Gerald and get their cohort. So I want you to make your environment look like this. And then I would like you to see whether or not that works or not. Give it a shot.
Kyle, my environment file, oh, are you still there? My environment file didn't want to autofill add student like I would have expected it to. Does that indicate that something is not connected?
Perhaps. So do you have something like this in your cohort file?
Add student. Yes, I do.
Weird.
And it is saved.
I say give it a shot and see if anything breaks.
Okay.
Cool. Did it work?
It seems to have.
Ooh, exciting. So let's give it a shot. If I say, hey, new friends, yes, who are your students? Oh, just these two, that's who. And if I go, hey, Derek, yes, hey, Derek, who's your cohort? Oh, just this one. Gerald, who's your cohort? Ah, this one. Ta-da! Relationships. That's how you would hand roll one of these things. We're going to find out some other ways to do this over the course of the program, but being able to work through this logic, mighty good place to start.
So I just ran the same thing you did. I got the same thing back that you did, but it's like cohort, like the instance, it's like this long string of stuff. And that's like, I'm trying to think of how to say my question. How do I check if it's actually returning what I want it to? Like it's returning something, which is a good sign. But if some wires were crossed and that's not really in plain English, is there a way that would alert me?
Yeah, so if I go, all right, where's Gerald? So this ID is where Gerald's shit is being stored in RAM right now. That's an address. So yeah, all right, I think Jared should be in Empire. That's where Empire is being stored right now. Hey Gerald, who's your cohort? There we go. Same address. And Gerald's ID there and there. Now in practice, we could also, label these things. How would we do that?
Add an instance method for name.
Hey, beautiful. So if I go over to cohort and pass in a name and store in an instance variable, and then make it so that you can, yeah. So we can do that with cohorts now. No reason we can't also do it with students. Cool. And now when I'm making these new students, I can pass in the name. All right. Now let's see what happens if we run it. Hey, Ben. Yes. Ben, who's your cohort? New friends? Hey, Derek. Yes. Derek, who's your cohort? Who's in GIT? No one. Ta-da!
Could you just walk us through changing one of their cohorts?
Ooh, cool. So if I wanted to change someone's cohort, how am I to do that?
Well, I know you'll need a writer method to change it.
Sure. So I might have like remove student takes in a student. And then how would that logic work? Also an enumerable.
There is an enumerable just called remove, isn't there?
It might be.
Well, wouldn't you have to figure out which cohort they're in first and then remove them?
So depends. I don't know if we're doing that from the student side or the cohort side. If we're doing it from the cohort side, then presumably we know it already.
I guess we could also find that person and then like give them a new cohort assignment method.
It's exactly what we could do. So we want to do it on this side. What I'd probably be inclined to do is something like at students.select. I'll change the name student to remove so it doesn't fight with that one. And I want to keep everybody who is not the student to remove. Cool. Now you can remove a student. All right, so all of this is one way to do this. We could also do this from the exact opposite side. What if, oh, this is the last thing we'll do for lunch. All right, delete all this. What if I were keeping track of the cohort on the student? So maybe I give them a name, save it. What if I did something like add cohort and takes in a cohort? What if I store it on the student instead of the cohort? That works pretty well too. So I could do something like that. Now, what is this on the cohort side? If I want to find out who my students are, what would that logic look like? Need to be able to get all the students, part of it. What do I need to do on the cohort side to get all the students?
Could you show the student class again?
would we just kind of mimic the method we created in student before in cohort?
Yeah.
The .all.find.
Yeah, something kind of like that. So I could say student.all, except I don't want find. Find gives me back the first match. I want something pretty close to that, though. I want every student that matches.
Map?
Ooh, almost. Map is I want to take every student and turn them into a different kind of student.
Oh, find all.
Or select.
Select. That's the one. Select is going to give me back every match for whatever happens in this block. Okay. So what happens in this block? How would I know that a student is in my cohort?
Yeah.
Cool. I wonder if it works. Give these guys their name back. All right, so those all take in a name, those all take in a name. Cool. Yep. Add student. That's right, we're doing it backwards now. So we want to say Ben.add cohort new friends, like that. So I should be able to say, yo, Ben. Yo. Hey, Ben, who's your cohort? Oh, I got to give it a accessor. Adder, reader, cohort. Yo, Ben. You? Hey, Ben, who's your cohort? Cool. Hey, new friends. Yeah? New friends? Who are your students? Uh-oh. Something didn't work there. Anybody catch it?
We don't have a reader.
No, so we don't need a reader for this because there is no instance variable. It's calculated.
Is it something to do with when we initialize this?
Maybe. So cohort.new new friends, cohort.new empire, cohort.new get. It's all look okay to me. What about student.all? So self.all returns everything. We're packing that with every new student that we make. Initializing a name. Have this adder reader for cohort, which is happening down here. Might be worthwhile to initialize at cohort to something like that, so that it has a value. Ben is, we're calling the add cohort instance method on Ben, which should set his cohort instance variable. Okay, interessante. Try that again. All right, there's Ben. Ben's got that cohort. So name is new friends. New friends is right there. New friends for your students. Oh, interesting. So how am I going to debug this? You tell me.
Try it.
Pry it. You can do prize inside of prize. So I'm trying to figure out if student equals self. So what I can do is go, all right. This is the one that's confusing me right now. So it dumps me into another pry. All right, well, what student am I looking at? I'm looking at Ben. And then what about self? Ah, anybody catch it? What do I need to actually compare?
You need to compare the students' names, not the cohort.
Ooh, not the name.
Or the instance.
The instance.
Yeah.
So I don't want to compare student and self. I want to compare student dot cohort and self. Those are the same thing. So I want to compare student dot cohort and self. So now when I do that, student dot new friends dot students. Oh, just Ben, that's who. The important idea with doing this in Ruby is that it's only in one place. Because I should be able to do this from the other side. So like I'm saying, I'm adding a cohort to this student. I still want to be able to add a student to a cohort. Can anybody think of what would happen on this line to add a student to a cohort?
You could say student dot add cohort self.
Ooh, interesting. I like that. Nice. I wonder if it works. Let's try this from the other side. New friends dot add student. Oh, let's get Derek in there. You know what? While we're at it, I want to go ahead and throw Gerald in too. Sorry, Gerald, you're getting kicked down to the minors. Does it work? Hey, new friends. Yeah? Who are your students? Oh, just these three, that's all. Ask me some questions.
So when we're reading these instances in the pry right here, the bracket in front of student corresponds to the bracket after Ben, and then it's like cohort and new friends inside the other brackets.
So this square bracket here.
Sorry, the pointy brackets. I don't actually know what they're called.
Angle bracket, you can call
Angle
it.
brackets. Okay.
Yeah, all of that is Ben. And then all of this is Derek. And all of that is Gerald.
And then the cohort points to the cohort instance inside the other.
Exactly.
Okay.
So that cohort starts there and ends there. But big takeaway, this is like most common mistake once we start working with this stuff and start working with these comparisons. You're comparing the instances, not the names. You can have two instances, two completely different instances that both have the name new friends. Don't compare the names, compare the instances directly. Other questions?
you mind flipping back to your student file?
Not at all.
Oh, I'm sorry, the other one, the cohort file then. Thank you.
So self references a specific instance. So it's self-referential. It's saying, this is me.
Mhm.
Okay.
Inside of an instance method. So there's only two things that self can be. It can refer to the instance or it can refer to the class. Here, it's referring to the instance. Here, it's referring to the instance. Here, it's referring to the instance. Here, it's referring to the class. It's referring to capital S student. If it's outside of a method, that's the class. If it's inside one of these methods, it's the class. Everywhere else, it's the instance.
And what that method does is show us everybody who has the class student, or every object that has that class.
Yes, that's exactly what it does. We're using it right there. Cool. We got a luncheon we're late for. I'll see you guys over there. Cheers.
Thanks, Kyle.